This is problem 6 in chapter 7, and it's our first problem on work. Work is the way in which energy is added or taken away from a system. In this particular problem, we have a mass, a wagon with a child in it, and we have somebody pulling on that mass, so that will that force on that mass will accelerate it. And so if we view the system as the wagon, the mass, then we see that by pulling with a force, we are then adding energy, kinetic energy in this case, to the wagon and increasing the energy of the system by putting work into it. So in this situation, we have a man pulling with a force of 50 newtons at an angle of 30 degrees over a distance of 30 meters. So the definition of work, if we remember, is equal to the perpendicular component, the parallel component of force times the distance traveled. Okay, so we need to find the component of force along the distance of travel, direction of travel, and so that would be 50 newtons times the cosine of 30. So the parallel force is equal to 50 newtons times the cosine of 30 degrees. Okay, and that ends up equaling, and then we multiply that, whatever that is, by the distance that it's traveled. So the work equals 50 newtons times the cosine of 30 degrees times 30 meters. And when you do all that together, that's 1,300 joules. So let's refresh our memory here. We've got a mass, that's our system, and we're pulling on it with a force. That force is not completely in the direction of travel, so we need to find the component that is. We call that F parallel. And F parallel in this case is 50 newtons times the cosine of 30 degrees. And then we multiply that value times 30 meters, which is the distance traveled, to get a total of 1,300 joules.